Welcome students, welcome to Physics and Chemistry Made Easy. Today's topic is about screw gauge. Another instrument, screw gauge. Now screw gauge works on the principle of screw and nut. So the principle of screw gauge is screw and nut. Right. What does it mean? Let me draw a screw. Right, screw. These are called helical threads. These are called helical threads. Right. There is a nut over here. Very good. So nut. Right. This is axial line. It will let us draw one axial line. This is called head of the screw. This is called tip of the screw, or even you can call it as tail of the screw. So why you are saying that principle of screw gauge is screw and nut? That's an interesting thing. Bring the screw to the top end. Top is what? Head end. Okay. So you have brought this screw here. Okay, good. So screw is brought over here. Now you are not able to see any thread. Right. So these are called helical threads. The screw is here. Sorry, nut is here. This is nut. What you are supposed to do, you have to turn the nut for one complete rotation. That means let us mark a dot over here to the axial line. Now you turn this nut for one complete rotation. One complete rotation you have to turn. Right? To record what? Pitch of the screw. This is called pitch of the screw. What do you mean by pitch of the screw? It is distance traveled by the screw by number of complete rotations. So actually what happens, if you turn this nut for one complete rotation, then this nut moves over the screw for a distance of 1 mm. That means the distance between these two helical threads is 1 mm. The distance between two helical threads is 1 mm. The distance between these two helical threads is 1 mm. So when you turn this nut for one complete rotation, that means when you turn it for one complete rotation, this nut moves a distance of one helical thread. The distance between two helical threads is 1 mm, isn't it? Therefore, it moves 1 mm. For one complete rotation, it moves a distance of 1 mm. That is called pitch of the screw. So it's 1 mm for one complete rotation. Therefore, the answer is 1 mm. Now, what we have to find the least count. Formula to find least count is same thing, which is pitch of the screw. Pitch of the screw by number of head scale divisions. What is the pitch you got? 1 mm. Screw gauges are of two types. Some screw gauges have a head of 50 divisions. Some screw gauges have a head of 100 divisions. If it is a 100 division screw gauge, then the answer will be 0.01 millimeter, or it is 0.01001 centimeter. This is how we find the least count of a screw gauge. So the screw gauge works on the principle of screw and nut. So I have drawn a screw. This is a screw and this is a nut. These are called helical threads. Helical threads. The distance between two helical threads will be 1 mm. 1 mm. If you turn the nut for one complete rotation, means what? You have kept some indication line, axial line. So I dot here, exactly coinciding this axial line. Now if you turn the nut for one complete rotation, screw advances a distance of 1 mm. For every one rotation, it advances a distance of 1 mm. And this particular 1 mm is what? The distance between two helical threads. Okay. So what happens is, first thing when you speak about screw gauge, when you work with the screw gauge, you will be given screw gauge. Right? First we are supposed to find what? Pitch of the screw. How to find pitch of the screw? First what we are supposed to do is, yes, this is the screw gauge. You can see the screw gauge. I'll turn towards you. This part is called stud. This is immovable. Immovable, does not move. This is called shaft, which is movable. So you can see the helical threads over here. Right? Helical threads. These are called helical threads. The distance between two helical threads will be 1 mm. It depends upon. Okay. So actually what happens, see, we are supposed to turn, we should not hold this part, okay? We should hold this part and turn the screw gauge like this. So I am moving the shaft towards the stud. I am moving the shaft. So once again I am going back. I'll tell you. So you will find pitch scale readings over here. Pitch scale readings. Right? Right, very good. These are called pitch scale reading. So what happens? These readings are visible and there is a zero here. There is a zero which is pointed downwards. But actually speaking, what happens? The readings on the pitch scale are like this. Now this is axial line, as I was telling you, this is axial line, and the readings are like this. This is pitch scale 0. Then comes 1, 2, 3, 4, and 5th division, 6, 7, 8, 9, and 10th division, like this. So what happens, when you join stud and shaft. So as I was telling you, this is stud and this is shaft. When you join these two, what happens is, this part of the barrel, we call it this heads. This part is called as barrel. Okay. The barrel comes on 0 division of pitch scale. It will come out like this. So this is parallel, like this it is. So these readings are not seen. At the same time, these readings are not seen. All these readings are not seen. What is seen? 0th division of the pitch scale is seen. So what happened when these two joined each other? When the shaft is joined to stud, stud is joined to shaft, what happens is, this head scale exactly comes over 0 division of the pitch scale. Right? Now what to do? Now you have to turn, and meanwhile I forgot to tell you, this is called head scale. This is head scale. And it is of, sometimes it will be of 100 divisions or 50 division. So you can see a screw gauge here. Right, a screw gauge, I brought a screw gauge here, and this has 50 divisions. You can see the divisions over here. You can see the divisions over here. 50 divisions screw gauge. This is a 50 division screw gauge. Right. So this is for 100 division, 100. So now what to do? Pitch scale 0 is here. Can you see the pitch scale 0? Yes, to some extent, because it has exactly come on the pitch scale. Now what to do? Turn this barrel. That means at this time, your 0 division of the head scale. This is called head scale, and these readings are called head scale reading. Just now I told you it will be either of 100 or 50. Now what happens when you bring these to stud and shaft? So it is a U-shaped frame like this. This is called stud. This is called shaft. So you brought shaft in contact with stud. So these are pitch scale readings. First reading is what here? Like this, 0, it is 0. And 1, 2, 3, 4 and 5 it goes on. But what happens when these two are brought close to each other? Head scale is on the 0 division of the pitch scale. Head scale is on the 0 division of the pitch scale. That means head scale pitch scale readings are not seen because barrel has occupied that part. They are not seen. So this is your axial line. But what very interesting thing is what? This is your pitch scale 0. So barrel has come over the pitch scale 0. This is your axial line. Axial line will coincide the 0 division of the head scale. This axial line coincides at 0 division of the head scale. Now what happens? 0, isn't it? So turn this barrel for one complete rotation. Right? Bring back again to 0. When you bring it back to 0, it moves back showing you the first reading. It will show you the first reading, that is this reading, 1 mm. Now for how many rotations did you get this 1 mm? You got it for one complete rotation. So pitch of the screw is equal to distance traveled by the screw, for one complete rotation. That means a number of complete rotation only, but it is 1. So 1 by 1 I got it as 1 mm. That is my pitch of the screw. After finding pitch of the screw, you have to find least count. Least count is equal to pitch of the screw by number of head scale division. So number of head scale divisions can be 100 or 50. Depending upon that, you will get least count. So in millimeter it will be 0.01 mm if it is 100 divisions 1, and in centimeter it will be 0.001 centimeter. So when you are given a screw gauge in the lab, first thing what you have to do is you have to join the stud and the shaft. When you join stud and shaft, what happens? This head scale will come over the 0 division of the pitch scale, and this axial line will coincide the 0 division of the head scale. What did I say? When you join these two, okay, this is called axial line. So 0 division of the head scale will come in contact with the axial line. And this is a pitch scale 0. Pitch scale 0, this head will come over the pitch scale 0, exactly over the pitch scale 0. You can just see the 0, but you will not see the first line. It is not clearly visible. Now what happens? You have to turn this head for one complete rotation. Since you know axial line is in contact with 0, you turn it back again to 0, one complete rotation. So when a nut is turned for one complete rotation over the screw, nut moves to a distance of 1 millimeter. That is what you call pitch of the screw. Once you find